What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the Tutor, and today we're going to be talking about special triangles. There are two special triangles in trigonometry or pre-calculus that you should get really familiar with. They are going to be the 30-60-90 and the 45-45-90 triangles. These triangles are very useful in trigonometry because the ratios of their angles and their sides are going to give us some values that are going to become very useful later in the course. Today we're going to be looking at how we got to the 45-45-90 and the 30-60-90 and some useful relationships that we should already know heading into trigonometry. Let's take a look at this unit square. Remember that by definition, squares have equal sides and all their angles are 90 degrees. Now if we take the unit square and we cut it along one of its diagonals, we end up with a little triangle, which it happens to be a right triangle. And if we separate it from the square and draw it up here, we have an isosceles triangle that happens to be right. Now, if we wanted to find the area, we could, but that's not the interesting part. What is the length of its hypotenuse? And we know that by the famous theorem of Pythagoras, we know that we have a squared plus b squared equals c squared. And in this case, a is 1, 1 squared is 1, plus b is 1, 1 squared is 1, equals c squared. And when we add these two and take the square root, we end up with the square root of 2. Now, if we have a bigger square, say a square with sides length 16, we can do the same thing, right? We could just take this diagonal, 16 squared plus 16 squared equals c squared. 16 squared is 256, so we have 256 plus 256 equals c squared. Now instead of adding them, what I'm going to do is I'm just going to say these two are equal to 2 times 256. And this is equal to c squared. And then when I take the square root of both sides, this 2 stays inside, this 256 comes out as 16, and we end up that this length is going to be 16 root 2. Now, for those of you that are thinking, well, you also get a positive and a negative out of that. Yes, but since we're talking about length, we only take the positive root. Now, in general, if you have a square of side x and you cut it along its diagonal and you have a right angle there, we know that this side is also x. So then we know that to find the diagonal, we say x squared plus x squared equals c squared. When we add these two, we end up with 2x squared equals c squared. And when we take the square root of both sides, we end up with x root 2 equals c. So we end up with x root 2. So in general, notice that when we have this particular triangle that seems to appear whenever we cut a square in half, we are going to get this situation. Furthermore, since we cut it out of a square, and since we know that the corner of a square is 90 degrees, we also know that each of these angles is 45 degrees. So what we have here is a 45, 45, 90 triangle. Now, there's a few nice things about these types of triangles, the 45, 45, 90. First is the fact that since there's a right angle already in here, and since we know that this is isosceles, we only really need to know that one of them is 45. And that's going to become kind of important, even though it seems like something trivial when they start giving you problems like this. The nice thing about the 45, 45, 90 is that when you're given one side, it is pretty easy to figure out any of the other sides. Let's take a look at this one over here. We know that if we set this equal to x, then this side is automatically also x equals root 5. And we also know that this side is automatically x, which is root 5, times root 2, which is equal to root 10. So right away, we're able to figure out our sides without having to do too much math, as long as we know that our triangle is a 45, 45, 90. Another situation that occurs is that sometimes they just give you the hypotenuse. So they're telling you that this is a 45, 45, 90. They just need to give you one angle to let you know it's a 45, 45, 90. But they tell you the hypotenuse is 4. How do we find these over here? Well, we go back to our relationships here. We know that this hypotenuse is supposed to be equal to x root 2. So we're simply going to say x root 2 equals 4. And now we're going to solve for x. So divide both sides by root 2. These root 2's cancel. On this side, we get x equals 4 over root 2. And we know we don't like to have radicals in the denominator, so we're going to rationalize by multiplying by root 2 over root 2, which is going to give us 4 root 2 over 2. And after simplifying that, we get 2 root 2. So now we know that this is x. X is 2 root 2. So therefore, that means that each of these sides is 2 root 2. And if you would like to perform the Pythagorean theorem to verify that when you do it, you actually do get 4, you can go ahead and try that out. The next triangle that we're going to be talking about comes from the equilateral triangle. So let us assume that this is an equilateral triangle. And hopefully, with the last example, you're able to see why I'm able to say 2x or 3x or 10x, and it doesn't matter as long as all three sides are equal. But as we progress with the problem, you'll see why I chose 2x and not simply x. So let's say we have an equilateral triangle, and a few facts that we know about equilateral triangles are that all the sides are equal, and we also know that each of these angles measures 60 degrees. So that measures 60, that measures 60, and that measures 60. Now what we're going to do is we're going to drop an altitude from the vertex, or from the very topmost point. And we know that when we drop an altitude by geometry, this is going to be a right angle. And in an equilateral triangle, that altitude bisects both the base, or the side opposite, and also the angle. So now we know that if this was 2x, then each of these sides is going to be x, and this is why I decided to use 2x. And we know that that angle here is going to be a 30-degree angle. And because of that, we are going to call this triangle the 30, 60, 90 triangle. And now let's go ahead and isolate it and see what we can do with it. And now that we've isolated the triangle, now let's take a look at a few properties. Number one, notice that the smallest angle corresponds to the smallest side, and then the largest angle, which is the 90 degree, is going to correspond to the longest side. The only side that we need to find is this one. So let's go ahead and find it. We're going to find it with x, so it's going to make it a lot easier for us to tell what's going on. So let's go ahead and do that. Our a is going to be x, so we're going to say, well, let's go ahead and write a squared plus b squared equals c squared. Our a is going to be x, so we're going to say x squared plus, we're going to leave b as it is, so b squared equals, and then we have 2x as our c, so we're going to say 2x squared. Then we're going to say x squared plus b squared equals, so this is not going to change much, but on this side, we get 2 squared, which is 4, and then x squared. From here, I'm going to take my x to that side, subtract x squared, and I get that b squared equals 3x squared. And finally, we're going to take the square root of that, take the square root of that, and we get that b is equal to, well, this x can come out as the absolute value of x, root 3. So we get x root 3 mostly, that's how we're going to write it. And so we're going to get that this side is always going to be some proportion of x root 3 with the others. And this will be our 30, 60, 90 triangle. Now let us see how we can use this triangle. Suppose they give you something like this and they ask you to find that side, that side. So a few things that we know is that that's a 90 degree and that's a 30 degree angle. So by consequence, that's a 60 degree angle. So this is a 30, 60, 90, which means that we can automatically start drawing our triangle and say, well, if this is 30, then that's x, then that's 2x, and the one that's opposite the 60 is going to be my x root 3. Now we can say, well, my hypotenuse is 2x, so I'm going to say 2x equals 7. And from here, we're going to solve for x, and we're going to divide by 2. We get x equals 7 halves. X equals that, so now we know that. We're going to say this is going to be 7 halves. And finally, this is going to go there, so then this is going to be equal to 7 halves root 3. And now we can put it in our problem over here. We know this is going to be 7 halves, and this is going to be 7 halves root 3. That is all for today's lesson. I hope you learned something. If you did, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, drop them in the comments below. Thank you.